Recording, and we're live.
Let's go.
Welcome everyone to class today.
Oh my goodness. So not strong in the class.
All right, so this is the Babe Ruth problem, 68. Hits it 1 meter up, it's got to go over the fence. What's the minimum speed? So first, pretend like you know what the speed is and set up the triangle, vertical and horizontal. You don't actually know this, but you know that this term would be V Naught, whatever it is, times sine of 40, and this one's V Naught cosine of 40. I skipped the math on that. And then I think to myself, okay, let's think vertically now. So for the vertical part of the problem, that ball is going to go straight up and then it's going to come back down. So it's going to hit the correct height 2 different times. So he could hit it out of the park on the way up. In other words, when the ball is right here, it could be sideways fast enough, but he'd have to hit it really, really hard to do that. And I don't know that anyone really could. So for him to use the minimum speed possible, then you're going to use the longer time to go up to the peak and then come back down. That's the smallest speed. He could hit the ball and still have it move sideways 95 meters and just barely clear the 12-meter high fence. So my delta y is 11 meters. And now if I set up this equation, I get something like that. But the problem is I've got a t and a t squared, which is what I'm used to doing, right? It'll be a quadratic formula kind of problem. But now I have a v naught in here as well. There's no way I can solve with 2 unknowns in there, and one of them twice. So I have to come up with a way to get rid of the v naught, but I don't know what it is. So I'm going to try to use the x stuff to get rid of it. So if I rearrange this guy and think, okay, sideways it moves 95 meters in the time that it's in the air. So normally I'll go initial in the x is 95 over t. But I don't know t here, but I'm just going to go with it and hope that this somehow works out for me, even though I don't really know how it will. So I substitute in V naught x, which is the cosine guy up here. I'm going to rearrange this to solve just for V naught, because then I can get rid of that V naught. So it's 95 meters divided by t, and then this is cosine 40. Substitute that in, and then some beautiful, beautiful magic happens. Okay, not that beautiful, but some magic does happen. Notice the t's are going to cancel out, top and bottom. So we really have 95 meters times sine of 40, which is just a decimal, divided by cosine 40, which is another decimal. Or if you want to be fancy pants, you can remember sine over cosine is actually tangent. And you could just get rid of those and put tangent 40 in there. Anyway, once you've done that, you'll come up with that decimal times 95 is this, and then the rest of this is, these are just numbers with a square over here. In fact, notice I've lost the quadratic formula thing, or I don't have to have the quadratic formula because now there's not a t here anymore. So now I just rearrange, divide through, and then take the square root. And we come up with 3.7-ish seconds. I'm trying to find the minimum velocity, so if I take that, plug it back in here to this guy for time, then I come up with the initial velocities around 33 meters a second.
For those of us who are lost, could you go over that again?
No one's lost when I explain things, so.
You're right.
Okay, give me what you mean.
Like, find out how you get
Yeah, how did you get that equation for V naught?
Okay, hold one at a time now.
How did you get sine 40 over cosine?
Okay, do you see how I got this term?
No, go back.
Do you see how I got this term?
No, that's where I'm lost.
Okay. So I'm saying how fast is moving sideways, which is moving down. This thing right here, V naught in the x.
Yes.
Yep.
That guy right there is simply the distance it moves sideways, the 95 meters, divided by the time it takes the ball to go up and then come to this spot right here.
Okay.
So that's determined by the vertical guy right here. The time it would take vertically to go straight up and to the same height, 12 meters as the fence, or 11 meters higher, is this time right here. So So whatever that time is, divide it into 95, and that's how fast this thing has to be moving sideways so that it gets to the fence by the time the ball has dropped down to the fence height, vertically. Okay, so I got that. Now I substituted in V naught x is V naught, whatever that is, times cosine of 40. And that is this term right here. Okay.
You're wondering how we got V naught cos 40.
This was just, I skipped the algebra.
Yeah,
Cosine of 40 is V naught in the x over V naught. And I rearranged it and got that.
yeah, I'm good there.
Okay, so now I have this, which I'm going to solve for V naught, which means just divide by cosine 40 on both sides. And I get this when I do. And now I'm going to take this term and put it in the place of V naught up here, because I don't know V naught. And I can't solve this equation when I have t that I don't know and a V naught that I don't know. So I've got to get rid of V naught, so I substitute in there, and it does some nice canceling when I do. This t cancels with that t. And now I have 95 times sine of 40 on top, cosine of 40 on the bottom. This just ends up being a number, whether you keep it like that and divide or substitute tangent 40 in, because tangent is sine over cosine.
Why did you 95 go outside of your sine of 40?
I just redistributed that a little bit. I rearranged it. I slid the parentheses over here to sine and cosine so that it was obvious that they were tangent. And so I just moved them out of the parentheses. And then the rest is just simplifying.
Yeah.
Okay, any other questions on that?
Is there going to be a question like this on the test?
No, I'm not going to give you one like this on the test.
Yes.
Thank you.